Hello and welcome to Tribe Topper. In this video session, you are going to learn about friction. So, what is friction in fact? We would say, it is an opposing force which restricts the speed and efficiency of any machine. You know that the cars you use, there is so much of friction between the tires of the car and the road. So your car is all the fuel that you have in your car, the petrol or diesel, is not just used in running the car but also in overcoming that friction. So because friction is always trying to oppose your motion, and it depends on the reaction that is received by an object. So that would mean that if you have heavier an object, greater would be the reaction, and so larger would be the frictional force. Like if I ask you, you have to drag a chair or a bed. Of course, which one is easier? To drag a chair, because it is lighter, so there'll be less friction offered. But if you want to push a bed, it is held very strongly by static friction, and because of the heaviness of the bed, the static friction is also very large. So we can say that frictional force is directly proportional to the normal reaction. You can use R or N, that depends, but R is denoting the normal reaction here. So F is equal to, we had a constant here, mu times R. This constant mu is called the coefficient of friction. And since it is the coefficient of friction and introduced as a constant, it actually depends on the nature of the surfaces in contact. It depends on the nature of surfaces in contact. Now, this formula is very, very important. If the object is moving, we call it as dynamic friction, and if the object is at rest, then it is held by static friction. So you have mu s, which is the coefficient of static friction, and you have mu d, which is the coefficient of kinetic friction or dynamic friction. And the formula is still the same, that frictional force would depend. Obviously, if something is heavy, it is difficult to move. So force of friction would be still equal to mu times R. So if we want to define the coefficient of friction, then we would say, because force of friction is equal to mu times R, therefore mu would be equal to F by R, right? So mathematically it is equal to what? It is the ratio of the frictional force, which is resisting the motion of two surfaces in contact, to the normal reaction force, which is pressing the two surfaces together. So you can see here the normal reaction force, which is acting upwards. This decides the static friction, and the coefficient of friction depends on the force of friction that is being exerted over the normal reaction. Now in this situation, if I say that all these arrows, as you can see, they are of the same length, so all the forces are equal and opposite. So the weight acting downwards is balanced exactly by the normal reaction as per Newton's third law. And if the object is not moving, that means the force applied is equal to the static friction. But the moment your applied force, F applied, is going to be greater than the static friction, the object will set into motion. So object starts moving, right? So you have to figure out whether your object is in equilibrium or not, depending on the value of these forces that are acting on it. The next thing, which is frictional force, is centripetal force. This is very, very important, because as I told you, there is always a source force. Like I told you, in planets, in the previous session we have learned that if there are planets moving around the um, sun, and there are electrons moving around the nucleus, then there is a source force which acts as the centripetal force. Now what force do you think should be acting when a car takes a turn on a horizontal road? So when your car takes a turn, you are going straight. The moment you turn the steering, a force acts in exactly perpendicular direction and makes the motion of the car as a curve. So now when you are turning, you do not skid. And why you do not skid? Because you have you are under the impact of a centripetal force acting towards the center. Now, who is providing that centripetal force? So, it is the frictional force between the tires and the road which provides the centripetal force, so that your object, your car, scooter, bike, whatever it is, it will remain in that circular path and not skid away. You might have noticed, like when the tires are worn out, or when it's wet mud after a rainy day, there are high chances of slipping out. You can skid away because you do not get enough centripetal force to keep you on track in that circular path. Because if there is less friction when the tires are worn out, then that friction will not be sufficient to provide the centripetal force. Or due to wet surface also, the friction reduces and hence you do not get enough centripetal force. So that's all in this video session. In the next video session, you're going to understand some of the problems based on centripetal force and centripetal acceleration. Thank you.